Hello, everyone. My name is Flavio Popescu. I am a structural engineer at Strusoft, Denmark. I would like to welcome you all to today's webinar, which is entitled Working with Shells in FEM-Design. The point of this webinar is to have a look together at some common challenges, common tasks, common issues that the engineer or the designer would encounter when working with shells in FEM-Design. So we will sit together and have a look at FEM-Design and how it works when it comes to shells. We are using the GoToWebinar platform today. So please, if you have questions during the presentation, type them in the questions field. We will see how much time we will use for the presentation. This is the first time I'm having this webinar, actually, this topic. It's a new topic for me too. So I have not really estimated how much time it will take me to show everything that I want to. So let's take it step by step, see how it goes. And at the end, I can have a look at the questions that you have posted in. Also, if anyone wants to ask any questions afterwards, you're welcome to do that. Again, depending on time. Some of you may be here for the first time and hearing about Strusoft and FEM-Design for the first time. So I would like to make a short presentation about who is Strusoft and what we do. I've mentioned FEM-Design, which is our 3D finite element method software. And we will have, the program will be in focus today, but there are also several other finite element software that Strusoft develops, like WinStatic for single element calculation and design, like beams and columns and frames. BIM energy, which is energy calculation. Impact, precast, and reinforcement for precast element production in factories. And pre-stress for pre-stressed concrete elements like beams and hollow core slabs. If we have a look at Strusoft's history in a timeline, we can see that it spans across a period of almost 40 years, starting from 1982, when it was part of Skanska Construction, and up to present day, when FEM-Design 20, the latest version of FEM-Design, has been released, and the acquisition of BuildSoft company in the Netherlands. We have users all across the world, with a high concentration in Europe and Scandinavia. And we have offices around the world, with the headquarters in Sweden, Malmo, 3 offices in Denmark, and our latest office in Finland. If we take FEM-Design into consideration, FEM-Design collaborates with a lot of software, and it is very easy to use in collaboration with other software. CAD drawings are easy to import and to use as reference for your 3D model. We will actually have a look at that today, more close. And then you have the BIM integration with software like Revit and Tekla, where you take the analytical model from this BIM software. You import it to FEM-Design, and then you work directly on the analytical model. Get results and, of course, design if necessary. I would like to point out that it is very important that the analytical model, even in the BIM software, in Revit, for example, it is consistent. As you know, there's these softwares like these BIM softwares contain not only an analytical model, there's also a lot more properties, but it is very important that the analytical model is consistent so that you get an appropriate analytical model in FEM-Design. So it's best to start with a good analytical model, even from Revit. FEM-Design can do a lot. FEM-Design is a modular software, calculation and design software. You have your calculation engine comprising of structural loads, finite elements, and analysis. And then you have the design modules separately, namely foundation, concrete, steel, timber, and composite. And there's also masonry, which is actually not pictured here. A very powerful feature that I would like to mention in FEM-Design is the cross-section analysis for concrete design. We're not going to focus on this today, but in particular, but I wanted to mention it. You can perform a cross-section analysis on a concrete plate, for example, or concrete wall. After you have designed it and set some reinforcement into it, you can actually take that reinforcement into account in the calculation and study the cracks in the long-term behavior. So what it actually does is it takes this plate with the reinforcement in it and starts loading it in an iterative process, identifying cracks along the way. Once they identify the cracks, the program reduces the stiffness in the nodes where the cracks appear and then continues to load it. So you would get an accurate behavior of the concrete plate or concrete wall with the cracks. The 3D soil module is also a very powerful tool in FEM-Design. It gives you a more realistic behavior of the soil and the structure together with the soil. It considers the soil as 3D finite elements, and it gives a much more realistic behavior than a bedding modulus model or a spring model. And you can study the behavior of the structure and the soil in one model. Another element that makes FEM-Design special is the development of the software. We get direct input from users, and a good example for this is the KCT. The KCT is our yearly workshop where we get together in our development office in Hungary, Budapest, and we invite users of FEM-Design, long-term users, long-time fans of the program, and we sit together with our development team and the users, and we have a couple of day workshop where we brainstorm ideas and the users give feedback of the program. So they're actually directly involved in the development of the software. The developers take this feedback and suggestions and implement them in the next versions of FEM-Design. FEM-Design has new versions coming out every year. and several releases throughout the year. But let's have a look at FEM-Design and get back to the main topic of today's webinar, which is working with shells. As I mentioned before, you can model almost anything in FEM-Design, especially when using shells. Shells are surface elements, which are actually plain plates and plain walls. You can also have profiled plates and timber plates, timber walls, and profile walls. So you can actually have any type of shape of walls and geometries. The possibilities are endless. And with also the plate tool, you can draw any type of shape and come up with different types of geometry. Very common is that you work with AutoCAD files, with drawings. So let me just drag a file into FEM-Design. The program lets me see all the layers that have been imported. And it is that easy to open a DVG file in FEM-Design. Of course, as we're all aware, having worked with drawings and architects and other qualified people involved in the project from different fields, installation or foundation or whatever, a drawing can be complex. So it is essential that you have the simplest drawing possible that you work on. So right now, even for this simple floor plan, I get all these kinds of lines, which I don't necessarily need. So I can either turn off these layers. Wow. And then use only the line that I actually need. In this case, I knew that it was this CL layer in my drawing layer here. So I want to make it as simple as possible for me. That's my point. Let's try to draw a plate here. I'm going to select pick lines, and it doesn't really matter what kind of material I use. I just right click on my line and then I have a plate. So easy enough. I've started with my plate, which can take any shape based on my CAD drawing. Let's say I want to build up and I want to start building some walls. I can go to plain wall and I'm going to choose again line by selection. I can obviously draw a wall like we've seen before and draw it here along the line. And I can also choose line by selection and right click on this curved line. And apparently my walls have been generated with no problem. So I can just continue. I am drawing walls, let's say in this corner. But what I always need to check, and this is a rule of thumb, this is a very good rule of thumb when modeling from scratch or performing any types of modifications to my structure, is to check what I have modeled. I can see that this curve here, this was generated as some strips of wall, some rectangular strips of wall. So it's not actually a curve. It might be easy to see here that these walls are not actually aligned with my plate. But these small irregularities can be half a millimeter and not easy observable by direct eye check. So a very good tool and a good rule of thumb is to use the finite elements. The mesh is everything in a finite element software. So I can choose, let me see. I can use this, let me do that again. I can use this generate tool in the finite element mesh, and I just select my the region where I've made that modification, and I can see that I get a mesh error. I get a local refined finite element mesh, very small angle. So that tells me that there is something wrong with that region. And it is so important to fix this right away and not move on with modeling. Because if I move along and I don't verify and check this connection, in 8 stories from now, when I go up, this will be even harder to see. Even though the program will tell me that there's an error, I can so easily lose track of what I'm doing and where the error might be. So it might seem a bit of a time in the beginning of spending too much time on this, but it is worth it at the end of the day and at the end of the modeling when you're ready to perform your analysis. So just use the generate tool and check to see if there's any mesh errors. There will pop up a message if there's a mesh error. So what I can do here, actually, I can, let's see, well, there's several ways I can do this. I guess the easiest way is to try to delete this plate and then start drawing along my walls. Let's just do this real quick. Also here, place some walls. And then let's draw the plate using the polygonal tool, just for fun to fix the issue and show some modeling options as well in FEM-Design. Then you know what, I'm going to turn off this layer. So I know I am snapping exactly on the wall and not on the drawing. Again, very important to snap to the object, to the finite element object, and not the drawing. I'm not really interested in that. Okay, let's see. And I close the polygon, and there I have it. Much better. I go ahead and check my finite element my finite element mesh, and that is very good. Again, whenever I make a modification, I do that. I check with the generate tool and make a quick mesh. Okay, let's move on. Let's have a look at some tasks, some common tasks that come when working with walls. Walls are shells, and I prepared this quick model, and we're going to work on this. We're going to try to do some tasks on this model that are pretty common for structures of this type. So bear with me while we explore the possibilities in FEM-Design when it comes to working with walls. As you can see here, I have some walls already defined with some holes, and that's about it. Very important when working with walls is the edge connections. Let's start there. So each individual wall has edges, and each of these edges can be customized. If I go to my plane wall tab, I can see that I have the edge connection tool here. And if I select this wall here, I can select its bottom edge. And if I go to data, I can see that I have all the degrees of freedom and the stiffness for all of my degrees of freedom. This means that I can set my edge connection in whichever way I want when it comes to transferring loads. I see here XYZ for force and for displacement, and XYZ for rotation. So force and moment. I have also some predefined types. Right now everything is fixed. I have some hinged options where only force is allowed. And I can also orient myself according to these directions. So X direction means X axis here in this picture. And Y means, so X would mean maybe shear force in between the walls here in this case. Y would mean compression and tension in between them, and then Z would be like out of plane force. Let's I think I've chose the bottom one, so let's just allow for, again, I'm doing this. Let's just allow for Y forces and only in compression. Also, I also have this function here where I can say Y detach, Y tension. So right now as it stands, I am only transferring loads in the Y direction in compression for the sake of this example. And I click OK. And I have set this edge connection like this. Let's try again. Let's select this wall again and choose my edge connection. Well, I have to start over. We'll define my edge connection again. What I can do is actually create a type. So if I go here and edit library, I can actually create my type here. I'm going to say horizontal. And here I can start setting up my my releases. Let's see. And again, detach Y tension. Give it a name. Click new. And then this type is actually saved here. Oh, sorry, it's this one. So I can actually use it afterwards. I can actually select multiple edges. Another good tip is to label these edges. So if I actually go here, general, I can just give it an identifier. And let's say horizontal, HZ. I choose the type, horizontal. Then if I label them like that with my identifier, I can actually select them afterwards. Also by line connection type and by identifier. So I can actually select them directly, all of them. I guess the more organized you are, the easier it is for you in all fields, I guess. Let's have a look at this edge connection here between these two walls. Let's say, guess I want X in shear, working in shear, and then again I want Y working in compression. So no tension. I'm just going to detach here. Let's see, in set, no, free. And then free, free, free. I can also set friction factor here. Let's just, for the sake of it, enter a different friction factor and give it an identifier. Let's say vertical. Let's say V, vertical, VC. So I've created this edge here. Just some examples of how you can set up your edges. Maybe in this connection here, in a transversal connection with the transversal wall, we can see that one as well. We can say transversal. And again, I want them to work in shear, maybe, yes. In Y direction, maybe not. No, I don't want to transfer any loads. And then in Z, I want some sort of, maybe. Or maybe it was in Y. Anyway, actually, yeah, let's have it free here too. I actually don't want any forces in that direction either. And set the rotation also for free. And there's my transversal connection. Of course, I can edit any type of stiffness here that I want to. And of course, I can create a type as well and save it. Also, there is this endpoint behavior. Right now, there's actually still some points, some nodes connected in between these. Even though I have an edge connection all along my edge, the endpoints are still connected. So I can use this endpoint behavior to select it, endpoint behavior, and say separate endpoint from environment. This way I make sure that everything is released along this edge, including the endpoints nodes. This is also, you need to be aware that if you are connecting a beam to this wall, so if I take a beam and then draw it like this, draw like that outside, and it's connected to this point, it will not be connected to this wall. So even though it's, because I released it in that point, in that node, this beam will fall down. So it will not be connected to the wall. Just need to be aware of that. Let's have a look at the bottom here. Delete that beam. The same goes for the supports. So if I have a line support, my supports here can be set up in the same way. I'm going to use this hinged predefined type. I might give it an, it's by default an identifier of S. And again, I can create my custom type of support. And then select the edge of my walls. Let's say I'm gonna have I might have an anchor or a column which uses end point support. I can use this truss member. Let's say I'm gonna have it, and again, I'm just using this example as an example. I'm gonna have it run all the way through my walls. 12 and 0.5 meters. So I actually I want this to be kind of like an anchor to have my walls to work in tension and hold my walls down. I can actually set the properties for it to only work in tension. Okay, and I want a point support here, which again only takes tension force. Only takes tension force, the other way. And again, I make sure I snap to the end of it. Yeah, just to have a point support as well, example. Okay. Let's say I want to make modifications for this. Maybe I don't want to, but I have to. Very common. I have made the model. Very common situation. I've created the model. I'm happy with it. The architect drops me an email and says, hey, we need to move some door openings. Can you do that for me? And send you a drawing. Yeah, just do them according to this drawing. So I need to modify my perfect model. It aligns perfectly and everything works. And I need to make some modifications according to the architect. So I'm gonna get the drawing. I'm gonna get the DVG from him, which I've seen that I can just drag and import into FEM-Design. So I can actually use this DVG drawing to make my modifications. Let's see how this works. I have the 2D drawing and it's I've imported and it's on the horizontal and I want to flip it vertical so I can apply it to my walls and have a better view. Well, I can use the rotate function and I'm actually going to need, let's do this from the beginning. I'm going to actually need a line for orientation and axis. I'm going to just draw them in all directions. I use the rotate tool, choose around an axis. So I'm actually going to rotate around this axis here. And then choose a point. Now, this looks a little bit better. Of course, this is a very simple model. And most of the cases, the drawing is not this simple and obvious and with such so few lines, which I've made here for the purpose of this demonstration. What I need to do is be, of course, very careful how I place this drawing to match my model. Now, what I'm doing is not really a thing for you to follow. It's not a rule to do it exactly like I'm doing it now. I'm just showing you a way to do it. Of course, the best way is for you to experiment with your own techniques. You might have it might be easier for you to for example, okay, this I know that this door opening here, I can measure it. I can measure the distance from this opening to this wall at 650, and because the architect said that it will be moved, right here is 450. So I can actually, I don't even need to have the drawing in my model. I can actually just look at it in my PDF or in my DVG viewer, and then measure and do measurements on my model. But sometimes I just need to use the DVG file for reference. Sometimes it's very useful. But again, here comes your best practice into action. There are several ways to do this, I guess was my point. Let's see, I know that I've drawn my walls. I can see that there's some thicknesses, of course, for my walls that come from the DVG drawing. There's my slab, probably. I'm just take it from there and then mount it on top of my structure like so. And I can actually see that, well, it matches, but I need to do the modifications here. So we've come to the point where I actually need to make some modifications on my finite element model. Again, several options. It's up to you, I think. I think this is the best advice, that you can do it in several ways, and which one works best for you is the one that you're going to go with. It's different from person to person. The most important thing for any type of method is to check the mesh. And we're going to see that right now. What I do is I see that my my door opening needs to be moved a little bit to the right. Okay. Well, first of all, I'm going to hide everything. Well, yeah, I'm going to maybe hide something to make my life easier. Maybe hide this back wall, also this, and also this. It's a bit better. You can also use a 2D view. Just going to show you, so it's there. If I use this 2D view and then I choose a 2D plane, the program just gets me in a 2D view. It might be easier to work like this sometimes, maybe when drawing these holes. But this way I cannot see what's behind. So it's also a little bit risky because I want to make sure I connect in all directions. I go to my 3D view, and then what I want to do is I want to just delete these walls here. Let's see how I'm gonna do this. I'm not sure yet. I'm gonna actually draw some helpful lines here. You know what? I'm gonna delete everything. I'm gonna delete this wall too. Yeah. And I'm just gonna draw it again. I'm gonna measure the height of this wall. Make sure that I get the right height. It's 3.2 meters. This is what I do. I measure once. I measure twice. Like the old saying, measure twice, draw, cut. No, measure twice, cut once. It's very similar in FEM-Design. Measure twice, draw once. Let's place it below. And then you know what? I'm going to say measure again. Use the finite elements tool, which I've mentioned, generate, and just get a quick mesh. Make sure that this mesh is clean. There's no issues when, especially when connecting with several elements. If everything is fine, then I can move on and draw my opening, my new opening. I'll start from here. And I'm just going to draw it like this. There's some holes here too. I can easily draw them using the hole tool. Pick lines. I just select my lines, and there's my holes for pipes as well. And let's say I want to split this region to get some forces in these sections here and get some edges. Actually, that's what I'm looking for. So I can then edit my edges. And again, I do whatever. I set up my connections here. It works in shear and Y direction. And set, maybe I just leave it like this for now, not to think about it. And then release my points as well, my endpoints. So I've made the modifications. I can also drag these. I can drag these edges. I can move my surfaces wherever I want to. I can take the edge from here and move it here. And then I'll also have this edge here. So it's really, that's why I'm saying it's not, this is the way you do it. I'm not saying that. This is a way to do it. The most important thing is that you have consistency in your mesh. That's the most important thing. Can I revert this? So always after making a modification, you generate a mesh and check. Let's see here. This I've done on purpose. I have some connecting walls here. According to my AutoCAD, it might seem like these connect here from the drawing a lot of the times, but I can make this simple. I can make this simple for the finite element program. I can just move this wall and just have, well, let's generate the mesh first, see what happens. I don't get an error, but I can see there's finer mesh there. It doesn't say it's a problem, but in the long term, the denser mesh you have, the longer time it will take for the calculation. And an error, a really small finite elements here might generate a problem somewhere else in the model. So I want to make this as simple as possible for the mesh. So I'm just going to take this whole wall and I'm just going to put it right on the edge there. Let's see how it looks now. Ah, that's better. And this is like regional mesh generation for some connecting elements. You can also do a full model check. You can actually delete all the mesh that I've generated. Let's bring back up all of my elements. And then there's no found mesh over here. Okay. And then just run a calculation. So I can do that for my whole structure. See here, well, there's nothing I can really do about that because there's a hole there. So the mesh is refined accordingly, but let's see. I can see that this is, for this example, I can see that my mesh is so nicely drawn across all of the surface, except in this point. Often enough, this means that there's an issue here. There might be an issue here. So what I do is I look at the structure right there and I zoom in. Oh, and I can see that there's actually a misalignment here. That's going to cause problems. If it doesn't cause problems now, it will most likely cause problems in my analysis or in my results or further in my modeling. So again, the mesh is a very good indicator of where an issue may arise. So best to check it as often as you can, as you get the chance, especially when you make modifications. Let's see. Yeah, I'll just delete this wall and then draw it again. Measure 3 meters. Draw. And then measure again, so to speak. Yeah, I think that's what I wanted to show you. Some tips and tricks for working with shells. With the more you use the program, the more projects you have, the more used you get to it, and the more tasks and tools you will use, and the more questions you would have and learn new practices. That's a better way of putting it. Feel free to contact me at any time. I'm going to put up my contact details again. This is my email address at Strusoft. And our website is strusoft.com. Keep an eye out for more webinars coming up here at webinars, trainings, events. Summertime is upon us, so we'll probably not be too many webinars during this time, but as soon as we get back from holiday, we're going to set up some more. So keep an eye out on our webpage, keep an eye out on our YouTube channel. YouTube Strusoft official. And here is where you can find all of our videos and training materials for FEM-Design. You can keep updated with any new videos that we make. Just kind of checking if there were any questions, and yep, some feedback. That's great. Let me see if I can answer some of these right here live. Otherwise, I will just get back to you in an email with the answers to these questions. Liang, the webinar has been recorded, so you will have access to the recording. If you want to see some of those moves again. Yes, yes, it will be shared. Yeah. Thank you once again, everybody, for attending. And I wish you a happy summer holiday and we'll see you when everybody gets back from the holidays. Have a great rest of the day.